Okay. Thank you, Santi Das. Thank you, Brinda, Rampal. Thank you. Aditi, Solanki. Yes, thank you. Savik Kundu. Thank you. So I'll start. I again welcome you to the day 3 of this online FTP on numerical methods, computation, optimizations using MATLAB and the C programming language. Very warm welcome to all the participants. I can see we have almost 41 participants available in online mode, and few are in the offline mode also at in my room where I'm sitting. So yesterday, Professor Kumar, he took Professor Jitendra Kumar from the IIT Ropar. He is the head of the Department of Mathematics at IIT Ropar. He told you about the numerical integration as well as about the numerical differentiation. So how to solve the definite integral with the help of numerical methods? Because if you have a very complicated function, like if you have a very easy function, let's say integral x into dx, you can easily solve it. X square by 2 will be the answer, and then you can substitute the lower limit and the upper limit. But if you have a very complicated function and you want to take the definite integral over a complicated function, it's very tedious job to solve it exactly. So in that case, we would be using the methods of numerical calculations in order to get some idea about the approximated value of this numerical of this definite integral. The numerical methods we are using at those places where exact solution is not possible. We can only go up to a approximate solution. We can only go up to the up to some accuracy of the approximate solution. And in the numerical methods, as I told you, you have to repeat certain number of steps again and again, and it's up to you how much accuracy you want. Suppose you want to have the accuracy, let's say fifth decimal place after the fifth place after the decimal, then you have to repeat all those iterations again and again. Okay. In that case, it's very good to use computer methods, computer language, because manually, if you will repeat again and again, you will do the calculation, then your solution may be with 10 pages, 20 pages, 50 pages. It may go up to the 20 pages also. Everything you are doing a manual job, just you are placing the values, the limits in the previous solution, and then you are getting a more accurate solution every time. So in that case, it's not advisable to solve all those numerical integration or numerical differentiation with the help of paper and pen. It's always better to write a computer program for that thing. And now just you have to tell how many iterations you want. Suppose you want 6 iterations, then you put n is equal to 6 and it will give you the better accuracy. So Dr. Kumar yesterday, he taught you about the numerical integration with the help of 2 or 3 methods. One was the trapezoidal methods. Second was the Simpson rule. Simpson was either 1/3 or 3/8 rule. Today, I will taught you how to make a computer C program of these methods so that instead of doing all these calculation with the help of pen or paper, you just write a program and then you have to just put the n the iterations how many time you want it, and then you will get the more approximate better accurate result. Okay, so let me share my screen with you, then I will tell you the C program for this. I hope my screen is visible to you. I'll just make it. Any participants? Rampal, Jyoti, can you write yes if you are able to see my screen? Is it visible? Okay, good. Thank you. Thank you all. So, trapezoidal rule, Professor Jitendra Kumar, he has already covered yesterday. I'm not going to teach you this trapezoidal method. I will teach you how to make a C program for this trapezoidal method. Okay. So, in trapezoidal method, you have to use this formula to find out the value of the definite integral between the limit a to b. This is the formula where we have h by area or the definite integral, like let us see this first. This is your integral, basically this is your function fx. This function looks like this, and you have to find out, in order to calculate the definite integral of this function fx over the limit a to b, you are basically calculating the area under this curve from a to b. So this area basically you need to find out. So how you will find out this area? You will divide this area into many small areas, and each that small area is basically a trapezoid. Okay, so you will be finding the area of these small trapezoid, and then you will sum up all those small areas so that you will get the complete area under this curve from x is equal to a to x is equal to b. So this is basically the trapezoidal method, because yesterday Professor Kumar also told earlier, in other definite integral numerical methods we were using the rectangle instead of trapezoid. But you will take the rectangle, then you will basically be getting an error due to this small area which will be covered here. Okay, like I can share my, I can use the, try again. I would like to use Microsoft board, the whiteboard with my digital pen. So this is not working. Let us see the paint option. This screen is not visible to you. Yeah, this is visible to you. Okay. So I'll take a new option. Okay. So here I can use my digital pen. Basically, in trapezoidal method, what we are doing, suppose you have a function fx like this, and here this is your x-axis and this is your y is equal to fx. The pen size is a quite bigger. I'll make it smaller. Okay. Again, I'll take a new one. Okay. So you have x here, you have fx here, which is y is equal to fx. Then suppose this is your function. You want to find out this area where you have x is equal to a, and here you have x is equal to b. So earlier, without the trapezoidal method, people were calculating the area under this rectangle. They were dividing this into small rectangles and they were finding this area. Okay. So they were saying that this is the value of the definite integral of function, like function fx dx from a to b. Okay. But then you will be getting an error because you will not be able to calculate the area which is here under this. So now instead of this, what we will do, we will make a small trapezoid like this one, This is second complete area we will calculate using a small trapezoid. And then we will find out the area of all these small trapezoids here. Okay. And then we will sum up all these area. So if you will sum up all these areas, then you will get this formula. Area will be h by 2. H is that small subinterval. Suppose you have n subinterval. Like I am taking this area, and what is the subinterval? Like here I have 1, 2, 3, 4, 5. I have 5 small trapezoids. So here my n would be 5, and then how I will calculate h? H will be b minus a divided by 5. Like this, I can easily find out the h. Okay. Is it working? Whiteboard. Anyway, whiteboard is still taking time. So now your aim is to make a C program for this formula, which is trapezoidal rule. Okay, now you understand how to make this program. Okay, so in order to make this program, we will divide it into 3 steps. First step is to give the values of the parameters as a input from the keyboard. So what parameters you have to tell to the program? First, what is the lower limit A, what is the upper limit B, and how many steps you want, means the value of n. So these 3 values you have to give as a input through the keyboard. Also, you have to tell the computer the function y is equal to fx. What is the form of the function for which you want to calculate this definite integral? Okay. Let's say the function, your function is y is equal to fx, and let's say this function is like this, 1 upon 1 plus x square, similar this function. Okay, so I want to calculate the definite integral over 1 plus x square dx and my lower limit, let's say 1, or let's say 0 to 1. Okay, and I want accuracy up to 6 iterations. So here I have to tell to the computer like my a is equal to 0, my b is equal to 1, and my n is equal to 6, and my function is fx is equal to 1 upon 1 plus x square. This thing I have to tell to the computer before writing the program. So my input will be 4 things, a, b, n, and fx. Okay, so how we can give these as input? Let us say here in the program. So this says the program starts from here, hash include stdio.h, hash include mat.h. So first we have to define the function. So in order to define the function, I will use a new technique of the C, which is called hash define directive. So whatever I will write like hash define fx. After that, whatever I will write here, the value, the form of the function, and in future in the program, whenever I will use fx, this fx, I will write only the fx. It will be replaced by this function. Okay. So basically here we are defining the function as a hash define directive, hash define fx, and then function is 1 upon 1 plus x square. In order to write x square, I am using another inbuilt function which is called power function. Okay, POW x comma 2. The power function tells you if you have this power POW sorry x2, it is basically x square. If I write POW x comma 3, it will be basically x cube. Okay, so this is a function to calculate any power of x. So what I am doing, I will define like directive, this is hash symbol, then I will write in C define, and then function fx, and what is this form? It will be 1 divided 1 plus power x2 means 1 upon 1 plus x square, and it will be closed. So this thing we have written here 1 upon 1 plus power x square. So here you can use any function like 1 upon 1 plus x cube or 1 upon 1 plus x to the power minus 1 by 2 plus 1 by 2, anything with the help of this. Now we have to give input parameters. Input parameters, I told you we have three input parameters. One is the lower limit, second is the upper limit, and third is the value of n. Okay. So for this we have to declare these numbers. Like lower limit is lower, I am declaring a variable lower. For the upper limit b, I am declaring a variable upper. And then for the step size, I am declaring a variable as a step size. They may be float, they may be integer, but let's say for time being, I am defining them as a float. And then I am defining another integer like I and subinterval. So now I am giving the input to the computer program printf enter lower limit of integration. So enter lower limit of integration will be printed on the screen, and then whatever you will type that will be going to lower variable. Okay, means the limit a. Similarly, enter upper limit of integration. It will be whatever you will type second times, it will go to the b, upper limit. And similarly printf enter number of subintervals, means how many subintervals you want, like n. So that will go to the subinterval. So with this printf scanf statements, three times I am using printf scanf. I am just entering the values of a, b, and n. Okay. So up to now, let us use this program. I'll just use this program. Up to now, what we have done, I'll just copy this and I'll paste this program in a online compiler. Okay, and I'll just close the program also. So if I'll run this program, it's saying enter lower limit of integration. What is the value of a? Let's say it is 0. So it will go to a, then enter upper limit of integration. It is b. Then b is 1, let's say. And enter number of subinterval, it is, let's say, 6. Okay. So far we have given only the input things to the program. And we have already defined a function also. Fx is equal to 1 upon 1 plus x square. So we have defined function here with the help of hash defined directive. Let's go further for this program. Now, how to find the step size? I told you step size is given by h. Okay. And this h, how you can find out? The step size h is the how many intervals you have in the total range. Total range is b minus a divided by how many total subinterval you have n. So this will give you the step size of one subinterval h. So that you can find out with the help of step size is equal to upper minus lower means b minus a divided by subinterval which is n. Okay. So with this you can find out the step size also. So I'll just add this also step size in our program. So I have added this step size also. Okay. Now main thing is that you should understand now how to find out how to write the code for this formula. Now you have all the inputs a, b, and you know the function y. Only thing is that you have to make a program in the C language which will calculate these formulas, which will do the calculation using this formula. Okay. So in this also we have three steps. First is that in this formula, if you can see this formula, I'll write here. Let's take a new board. So the formula is basically h by 2, then you have y0 plus twice y1 plus y2 plus dash 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 up to yn minus 1, then plus yn. This is your formula for the trapezoidal method which is given here. Okay. Now how I will make a program for this formula. Why I am giving so much time? Because if you know for the one program, one method, then you can easily solve other methods also, like Simpson 1 by 3rd rule, 3 by 8th rule, or other things. So in this, what I'll do, suppose the integration is, I'm saying integration is like this, I. Okay. So initially I will tell to my program that I is only y0 plus yn. Okay. This will I will tell to program that my integration value is only this. Now what I'll do in the second step, this was my first step. In the second step, in this I will further correct this formula. So in the second step, what I'll do, I will add these terms also, twice y1, y2, yn. These terms also to my program. Okay. So for this, I have to add y1 plus y2 plus y3 plus yn minus 1. It means I have to make a loop, like for loop or the while loop, in order to get the sum of all these functions which are starting from y1, y2, y3, yn minus 1. Okay. And that loop should go up to only n minus 1. We should start from I is equal to 1. Let's say I am making a for loop for this. For loop, then my I small I should start from 1. Condition should be I less than equal to n minus 1 and then I plus plus. Okay. In this for loop, now what I can do, I can start like I want to have sum of all these functions, then I can write sum is equal to sum plus then any first function f x, whatever we have defined, because we want to find out the value of this function, or maybe I can take x is equal to like I. So this program, and then we have to give I plus plus here. So in that way, from 1 to n minus 1, we will be adding all these function in a variable sum. Okay. And then I will add this sum with y0 plus yn. So basically I will be getting this. Suppose this is my I1, this is my I2. So if I add I1 plus I2, so what I will be getting, y0 plus yn, and then plus twice. Okay, I have not done twice also, so I can do twice I2, 2 into I2. Then I will be getting all this, y1 plus y2 plus yn minus 1. And then in finally in third step, I have to multiply this I2 with, in third step my I3 will be, I have to multiply it by h by 2, then I2. So in these three steps, I'll be getting all these things which are required in order to calculate this formula. Again, I'm telling you what we will do. First, I will calculate only y0 plus yn. This will go to I1. Now my aim is to calculate these things. These things can be calculated with the help of for loop. You have to start I is equal to 1, I less than n minus 1, I plus plus. Then you can start sum with 0. 0 plus first value of function y1. It will be added to sum. Then again I will be 2. Then y2 value up to n minus 1. So you will be adding all these value, and then finally you can multiply this by 2i2. Okay. So I1 plus I2 will give you the value which is there in the this big bracket. Okay. And then you multiply this I2 with h by 2, then you will get I3. And finally, your final value of the integration would be I1 plus I3, or maybe I3. It will come in I3 only. Okay, I1 plus 2I2 plus h into h by 2. So this will be your complete value in terms of I3. So let us see this program. What we have already done here. finding integration value. So integration, I told you first I'll take f lower plus f upper because we have already made a program, we have already made a hash directive for this function fx. So I'll replace x with a. A here in the program I'm writing lower. You can write instead of lower, you can write a or b also. So if I write f lower, then the lower limit will be replaced by x. Okay. So initially this is basically here f lower plus f upper means y0 plus yn because n will be the last limit. And then in order to get the y1 plus y2 plus y3 up to yn minus 1, we are making a for loop. We are starting with I is equal to 1, I less than equal to sub interval minus 1. Sub interval was n. So n minus 1 I plus plus. And then I'm putting into another variable k. So what will be the k? K will be lower plus I into step size, and then what I am doing, integration is equal to integration, because integration was having this y0 plus yn. Okay, here this integration is having y0 plus yn plus twice into fk. Fk would be having all these things, y1 plus y2 plus y3 up to yn minus 1. Okay, because every time we have to make we have to take the indices to the next value. This k is basically indices, like first limit is x is equal to a. After that what it is, let's say x0, then what will be x1? X1 you can find out like a plus I initially is 1 into step size. Your step size was h, because all the time if you see here, all the times you have these values, let's say x0, x1, x2, x3 up to xn. Okay, your x0 is a and your xn is b. Then the corresponding function will be y0, y1, y2, y3, yn. So how you will get x1? X1 is nothing but a plus 1 into your h, because your h was basically b minus a divided by n, means the difference between these two was h. The difference between these two, the difference, it is equal distance. Okay, this was h, this was h, this was h. Okay, so if you want to find x1, x1 will be a plus h, x2 will be a plus 2h. What will be x2? It will be lower limit plus 2 into h. What will be x3? It will be a plus 3 into h. What will be similarly your xn? It will be a plus n into h. And your xn is nothing but b. b is equal to a plus n into h. Okay, similarly what we have written here. It will be from this b minus a will be n into h, or your h will be b minus a divided by n. Okay. So this thing we are doing with the help of this k is equal to lower plus I will be varying from 1 to n minus 1, and then step size, which is nothing but h. Okay, so with this, we in the value of integration, I'll be having y0 plus 2y1 plus y2 plus up to yn minus 1 into yn. And now I have to multiply this final value by h by 2. Step size is h and then by 2. Okay, so integration into step size, which will be the final value. Then I will print it. Required value of integration is the whatever is contained in this variable integration. So do you have any doubt so far? Please write me in the chat window if you have any doubt, because I am trying to clear each and every step of this program, so that if you know the one program, you can make any program of any type of method of numerical integration. Okay, so if you have any doubt so far, please write in the chat window. I am giving you 2-3 minutes, you think, and then write in the chat window. If you have any doubt, please write in the chat window. If you have no doubt, please write no in the chat window. So that I can get the idea that you are there with me and you are trying to understand each and every step of this program. Thank you, Satyendra. He is written now. Thank you, Ankita. Thank you, other persons. So let us run this program. I'll just now add this calculation part also, the finding is integration value also in our C program. So this is my complete program. I have typed here. I have added this finding integration. So there was 3 steps. I'm again telling you. First was to give input, which is from here to here. Okay. And then the second part was to find out the step size. And third was the finding the final integration value. Okay. So let us again run this program and let's see whether you are getting the exact answer or not. When I'm clicking on the run, it is saying enter lower limit of this integration. Let's say lower limit is 0. Enter. Enter upper limit of this integration. Let's say upper limit is 1. Enter number of subintervals. Let's say I want 6 iterations, n is equal to 6. And then it is giving the required value of this integration is 0.784. Now, can you, because it's a very easy function, 1 upon 1 plus x square. Can you solve this integral and place the limit 0 to 1 and let me know what is the answer? Without using numerical methods, just trying to solve this integral 1 upon 1 plus x square, place the value of limit and then let me know the answer. Write in the chat window what is the exact answer. If you because it's an easy function, you can directly solve it. It's not a very complicated function. 1 upon 1 plus x square. Please try to solve it. I am giving you 5 minutes. Please try to solve it. Somebody is writing exact answer is 0.78. Can I see in my case? What is the exact answer? 0.785. Okay. So if you see here, I am getting 0.784, but exact answer says 0.785. I want to increase the accuracy. So what I can do, I can basically increase the sub intervals, like the number of iterations. So let's say instead of 6, I will use 10 sub intervals. So I'm again running this program. Lower limit a is 0, upper limit b is 1. Then sub intervals like n, instead of 6, let's say 10. And if I click enter, then you can see I'm getting 0.785 exact answer. So I'm just repeating all these steps 10 times, whatever I have written here. All these steps we are repeating 10 times and then we are getting this answer. Okay. You may go up to 20 times also. Let's say, because it's a simple function, the answer should not change because 0.785 is the exact value of the answer. So let's say if instead of 10, I'll take 20 subintervals. I'll run this program again. Lower limit a 0, upper limit b 1, and n subintervals. Let's say I'm taking 20. Then I'm getting 0.785 because I have already reached to the exact value. But sometimes here it was a very simple function, 1 upon 1 plus x square. But sometimes you may have the complicated functions. Then it would be difficult to get the exact answer. You will always be getting the approximated answer. And it's up to you how much subintervals you are using. If you are using more subintervals, you will get the better accuracy. Okay. So good thing with the programming is that now suppose another student is using a program which says 1 upon 1 plus x cube. So I'm simply replacing this 2 by 3. Then my whole program will remain same. Only function we have replaced it. Now I want to find out the answer. So 1 upon 1 plus x cube would not be so easy for you to solve. Okay. Can you try with the help of simple integration formulas? Can you find out the integration 1 upon 1 plus x cube and limit would be same 0 to 1? Can you do it? Can you please let me know the answer? Then I will run this program for 1 upon 1 plus x cube. Think about how can you solve integral 1 upon 1 plus x cube dx. Limits are 0 to 1. Think about it. If anybody has solved it, then means those who will be solving it, those who are getting the answer, they can write in the chat window. Integral 1 upon 1 plus x cube, limit is 0 to 1. What is the answer? We have many participants, but only few are writing why. We have with us Neha Singhal. Can you hear me? Can you write yes in chat window if you can hear me? I just want to see how many are really present or they have simply logged in and have gone for some other work. No, yes. Nirmala, Preetpal Singh, can you write yes in chat window? Okay, Himanshi is saying yes. Rupesh Srivastava, I'm listening you. Okay, that's okay. Just those only two. I'm calling the name. Only those write yes, not all. I'm sure many of you are there. Just I'm checking whether everyone is here. So if I'm calling the name of any student, any participant, then he or she has to write yes only. Rajesh Yadav, can you hear me? If yes, then please write yes in the chat window. Jaya Gupta. Okay, Jaya Gupta is there. She is writing yes. Very good. Harpreet Singh. Okay, Harpreet, thank you. Dr. Ashwani. Okay, that's good. That's fine. Let's take one or two more. Ankur Agarwal and Bikram Dhole. If you are there, please write yes. Okay, anyway. Uh, Anything has got the answer for 1 upon 1 plus x cube? I'm sure it's not so easy. If anyone has done, please write the answer in the chat window. So if not, no, if not, then let us try to run this program. Here I have replaced 2 by 3. Now my function is 1 upon 1 plus x cube. I'll run this program. Lower limit of integration, which is a, is 0. Upper limit of integration, which is b, is 1. Number of sub-intervals, let's say I'll take 4. And then my answer is 0.832. Somebody is writing something. Anuradha, can you please read out what the candidate is writing? Analytical solutions expression is really complicated. Yes, I do agree with you, and that's why we are using numerical methods. It's not so easy to solve the complicated functions with the help of definite integral formulas. So we will be using numerical methods. So let us see for 1 upon 1 plus करना पड़ेगा ना can hear me. Participants, can you hear this section? Can you hear me? Now, no. Yes. Now, still not. Okay, thank you. Hear me? That's the power. I think I'm audible. Now you can hear me. That's good. Voice is breaking. Voice is not clear. Voice is not. Okay, let us wait. Okay. Is it clear? Let us wait for. Now, now is it? Is it? Dear participants, am I audible to you now? Can you many microphones? It is repeating when we have all two microphones at this place. Maybe मैं यहाँ से अब देखना अंकिता अभी भी तो हो रहा है मोबाइल से तो किसी अलाउ नहीं है मेरी वॉइस कई विंडो से जा रही है आप ऑफ है आपके मोबाइल से कनेक्ट तो नहीं है मोबाइल ये रिपीट तब होती है जब एक से माइक्रोफोन हम यूज वो क्लोज बन जाता है प्रोफेसर विकास गुप्ता कैन यू हियर मी क्लियरली बट इसका आवाज भी कहाँ से आएगी मुझे इसमें तो अब participants can you hear me now? What is the situation? Can you hear me clearly? Okay, okay, yes, better. Okay, okay. So there was a power failure outside due to our system was shut down. Uh, uh, we have restarted it. This power failure network is the internet हमारे यहाँ पे problem मोबाइल अंकिता आप देखो हमारा आवाज क्लियर है क्या वॉइस participants now I think I'm audible clearly please check please write in the chat window okay thank you so I'll again share my screen so now I was telling you that I will increase the subinterval sorry I will increase the subintervals lower limit is 0 session ended please run code again upper limit lower limit 0 upper limit let's say 1 number of subintervals I am giving like let's say 12 my screen is not visible but I'm sharing my screen now visible okay good so let us see the answer the accurate answer is 0.835 now same we can make similar program for Simpson 1/3 rule also Ankita I'm audible okay participants if you face any issue in getting my voice suppose it's breaking or not coming clearly please write in the chat window so that I can come to know that you are facing any problem Thank you, Himanshi. It's all are okay, sir. Now, thank you, Himanshi, for your information. So now let us see another program for the Simpson 3 by 8 rule or 1 by 3 rule, how to make a program, because Simpson 1 by 3 rule has also been taught to you yesterday by Professor Jitendra Kumar. So let's see the program for Simpson 1 by 3 rule. So this is a program for Simpson 1 by 3 methods. Simpson 1 by 3 method, if you see Simpson rule, there are two rules. One is 1 by 3, second is 3 by 8, which are giving on the screen. Ankita, my screen is visible? आपका कोई किसी का माइक्रोफोन है? Panelist का. Okay. So in Simpson 1 by 3 rule, the formula is this. We have again repeat हो रहा है. कोई माइक्रोफोन ऑन है आपका? So here in Simpson 1 by 3 rule, I have h by 3, then fx0 means y0 plus 4y1 plus 2y2 plus 4y3 like that, and then up to yn. So here also what we will do, first for the integration, I'll take yx0 plus, sorry, y0 plus yn. I will add, means the value of the function at lower limit fa plus fb. Then here in between fa and fb, we have functions which has alternating 2 and 4. Like for first function we have 4, then second 2, then 4, then 2. So in order to sum up all these functions like 4y1 plus 2y2 plus 4y3 plus 2y4 up to xn minus 1, we have to use if else statement within the body of the for loop. Because if we are starting from y1, then for the odd functions like y1, y3, they have to be multiplied with a number 4, and all the even functions like y2, y4, they have to be multiplied by the even number with the number 2. So I'll use if and else statement within the body of the for loop, so that for the odd functions it will be multiplied by 4, and for the even functions it will be multiplied by the 2. Simpson, what is the Simpson 1 by 3 rule, 3 by 8 rule, how this formula is coming? That has already been told to you yesterday by Professor Jitendra Kumar. So I am not repeating this. I am just giving to the program. Okay. So you can see in the program here, like I will define the function first, define fx 1 upon 1 plus x square. And instead of using power function POW, I am just writing x, not x. But if you have higher powers, then you will use power functions. Then similar to our trapezoidal method, I will first give the input for the lower limit, for the upper limit, and for the subinterval. And then I will find out the h. H will be b minus a upper minus lower divided by subinterval n. Okay. Then in order to find the integration value, again I will do same thing. Integration was fa plus fb, means initial two values, like here given in this formula. Not proposital rule, but the Simpson rule. Here, given in this formula. 1 by 3, y0 plus yn, and then 4 y1 plus 2 y2. I can write this formula for the sake of the simplicity like this also, so that you can easily understand it. The board is not visible. Why not? Board is not coming. Whiteboard is not coming. It's taking time, I think. Internet is too slow. That's why it is like this. Yeah, it's now visible. It's taking some time. Yeah, now board is visible. So Simpson 1/3 rule, if you see, the value of integral is h/3. Then we have y0 plus, here we have 4y1 plus 2y2 plus 4y3 plus 2y4 plus so on up to yn minus 1. Depending on the even and odd, we will be having some multiplication here, and then plus yn. Okay, we will be having some value here. Okay, I'm just placing a star. Okay, depending on even and odd. So for the y1, y3, those who are the odd values, we are multiplying by 4, and the y2, y4, those who are the even, we are multiplying by 2. So I will use if and else statement. In if, I will say, suppose this is my I, okay, the index. Then I will use a remainder operator. I'll divide I by 2. Okay. If this, I'll or divide by 2 and then equal to 0. Okay. If it is completely divided by 2, I mean there is no remainder, then we have to multiply by one number, else we have to multiply by another number. So in that manner, I can make a program like this. For I is equal to 1, I less than equal to n minus 1, I plus plus. Then here this is the same, k is equal to lower plus I into step size. Means k is equal to a plus I into step size is h. Okay. Now within the body of the for loop, I have if statement. If I divided by 2 and we are using the mod operator, modulus operator or the remainder operator, and the remainder is 0, then we have to multiply the function with 2. If remainder is not 0, then we have to multiply the function with 4. Okay. So using if else statement, we can find out the values of like 4y1 plus 2y2 plus 4y3 plus 2y4 like that. And finally, the value of the integration, we will multiply it by h/3 here. So let us run this program. Other steps are same, only we need to change the formula of the method, whether it's a trapezoidal method or Simpson method. Okay, so let us run this program. Enter the lower limit of integration, let's say 0. Enter the upper limit of the integration, let's say 1. Enter number of subinterval, let's say 8. And the answer is 0.785. With the help of Simpson 1/3 rule, we are getting 0.785. Let us take the subinterval only 6, like we initially took in trapezoidal method. So again run this program. Lower limit of integration 0, upper limit of integration 1, and then subinterval 6. So here with this, it is giving the correct answer 0.785. But you remember when I did same thing with trapezoidal method, for the subinterval n is equal to 6, it was giving 0.784. It means Simpson 1/3 rule is giving better accuracy for less number of intervals compared to the trapezoidal method. Got my point? So only thing is that difference is coming here in if else statement, because in the formula for the Simpson 1/3 rule, you have a different thing compared to the trapezoidal. In trapezoidal, we were having 2 multiplied by same y1 plus y2 plus y3. But here we are having first multiplication by 4, then for the second 2, then for the third 4, like this. Okay. And how can you obtain this? Like for the odd function like y1, y3, it's multiplied by the 4. Okay. So same thing we are doing here with the help of if else statement. If remainder is coming 0, then it's basically the even, then we have to multiply by 2. But if remainder is not 0, like for the y3 and y5, then you have to multiply with the 4 or yy. Okay, so it's very easy. Similarly, you can try other methods also, like Simpson 3 by 8 rule. In Simpson 3 by 8 rule, this is the formula. You have to multiply by 3 by 8 into h. So finally, when you are calculating the final value of the integration, instead of multiplying by 1 by 3 into h, you can multiply by 3 by 8 into h. Then your first y0 and yn will remain same. But here in between, you are having 3 fx1, 3 fx2, then 2 fx3, 3 fx1. So accordingly, you can make a program to find out these values also, and then you can just find out the value of Simpson 3 by 8 rule also. So I hope this is clear how to write a program for the numerical methods, numerical integration. And I'm telling you, whatever the program I am using, this is not only the single program. You can write your own program in some different ways also. If you will see different books, the writers are writing the program for trapezoidal methods in different manners, not exactly with the same which we have written, but I have given you in a manner so that you can easily understand it. Again, I'm telling you, this is not a very good programming. What I have written here, it's like a vague programming, but for the beginners, it's very easy to understand. That's why I have chosen this kind of programming here. Otherwise, you may write this program in few steps also if you are a advanced programmer. Any doubt? Otherwise, I will close this Simpson 1 by 3rd rule, and then I will come back to the arrays, and then I will tell you how to write a program for forward difference table and backward difference table with the help of arrays. Okay. So any question? Please think about it if you want to ask anything. I'll be stopping my video, my screen. Then after 5 minutes I'll be sharing other screen where I'll be starting the arrays with you. Ankita, has anyone written anything in the chat box? Okay. Okay. Fine. So I am just again sharing my screen for the finite difference calculus, where I will tell you about the difference operators, forward difference, backward difference operators, and with the help of arrays, which we have already learnt in C language, how can we make the program for forward difference or backward difference table. What happened? So I'll be telling you about the calculus of finite differences. Okay. The calculus of finite differences deal with the change in the values of function which is having a dependent variable due to the change in the independent variable. Like we shall study the case where independent variable change by equal intervals. Okay. So let's say y is equal to fx is a function and the consecutive values of x are a plus s, a plus 2h, a plus nh. All are differing by a same interval h. So the value of fx corresponding the function. Can we have PPT of Jitendra sir? Amit, I have already shared yesterday around in late evening around 10. I have already shared the PPTs of Jitendra sir on Canvas platform. You can take it from the Canvas platform. I have already shared yesterday night around 10 p.m. They will be there all the time during your this FDP. Anytime you can see, you can download, you can go through those PPTs. Okay. So forward difference operator is nothing but del fx is equal to fx plus h minus fx. If you want to take second forward difference operator, it will be del square fx. Then again you have to take, sir, folder is empty. It's not showing. Have you checked it? Okay. So Amit, maybe I forgot to publish it. It is there in the folder, but you will be able to see when I will click on the publish button. Okay. So don't worry. After my lecture, I will publish it. I will click on the publish button. Then you will be able to see it. Okay. Good. So second forward difference operator, you again take the difference of del fx plus h and del fx. So second difference operator will be like this: del square fx is equal to fx plus 2h minus twice fx plus h plus fx. Then backward difference operator is similarly, you will take the backward sign like this. Del in the back opposite manner, it will be fx minus h. It means forward difference operator are defined by the points to the right hand side of the x-axis, whereas backward difference are defined by the points left on the left of the x-axis. Okay. Similarly, you can find out the backward difference operator for second order also. So let's take a simple example. Forward difference operator this and backward difference operator this. Be the first forward and backward difference respectively. Then you have to show the difference of these two operators are equal to the multiplication of these two operators. So this is a very interesting case. Like these are the two operators, backward difference and forward difference. Their difference, if you take, is equivalent to their multiplication. Okay, which is not common with other type of operators. So the definition of the forward difference operator, del fx is equal to fx plus h minus fx. Then the definition of the backward difference operator is equal to fx minus fx minus h. Now, if we take the multiplication of this, the forward difference operator and the backward difference operator. So forward difference operator I am not expanding, backward difference operator I am expanding fx minus fx minus h. Now I will apply this forward difference operator on fx and on fx minus h. So what I will be getting here is del fx minus, I am applying only on the second one. So it will be fx minus h. So then we will be, which is again the backward difference operator. It means I started with the multiplication of these two operators and I'm ended up with the difference of these two operators. Another fundamental theorem about these operators is that if you take the nth derivative of this, like second order, third order, fourth order, so fx is a polynomial. If fx is a polynomial of nth degree, then nth difference will be a constant. Means if you take del n fx, it should be a constant, and if you go one more higher, then it should give you 0 because it behaves like a differential calculus. Okay, so the n plus 1 order derivative of forward difference operator will give you 0 answer. So with the help of this, we can find out, we can do many things. Okay, like we can find out a missing term in any forward difference table or backward difference table, or in any function. Like we know the value of the function at different values of x. Okay, now we know only the value of the function. We do not know the exact form of the function. Like yesterday, Professor Jiten Kumar was also telling, if we do not know the exact form of the function, we know its value at some points. Now, if I am giving you any point in between, and I ask you to find out the values of the function at that point, then without knowing the form of the function, it's not possible to find out the value. But with the help of this forward difference table or forward difference operator, you can easily find out this. Okay. Now, what is the forward difference table? In forward difference table, I will make a table with the column like x, then function fx, and then first difference, then second difference. Okay. First difference will be fa plus h minus fa. Second difference will be fa plus 2h minus fa minus h. And you will write in between of these two. Like if I'll tell you using the soft Microsoft whiteboard, then you can make it a table for forward difference table. So you have x, then you have function y is equal to fx, then you have first order del fx forward difference, then you have second order del square fx, then you have third order del cube fx, and then so on. You have del 4 fx. Okay. And this is for the equal interval. The difference between the x should be equal. So let's say take a practical example. If I have here, let me see if do I have some practical example here. In this, let's see this example. Construct a forward difference table. The function is 0, the x values is 0, 5, 10, 15, 20, 25. So I can write these values of x here. 0, 5, 10, 15, 20. Why I am telling you this? Because I will make a computer program. I am doing manually here, but after that I will tell you a computer program to calculate this difference table easily. I am sure you already know about this, what I am telling you manually, all these things. And the function values is 7, 11, 14, 18, 24, 32. The values is 7, 11, 14, 18, what was 21 and 32. What same? 24, 18, 14, 18, 24. Like this. Now, in order to take first forward difference, you have to take difference of this 7 minus 11 minus 7, because first order difference at fx plus h minus fx. Fx plus h is 11 minus 7. So 11 minus 7 you will get 4. Okay. Then 14 minus 11 you will get 3. Then 18 minus 14 you will get 4. Then 24 minus 18, this to this, what you will get? 6. Then 32 minus 24, what you will get? 8. Now for the second order difference, you will again take 3 minus 4. What will be? Minus 1. 4 minus 3, 1. 6 minus 4, 2. 8 minus 6, 2. So I'm again writing in between of these two, so that it will be like conical shape. Then for the third order difference, I'll take 1 minus minus 1. So it will be 1 plus 1, 2, 2 minus 1, 1, and then 2 minus 2, 0. Okay, I'll take now fourth order derivative. It will be 1 minus 2. It will be minus 1, and it is 0, minus 1, minus 1. And let us take fifth order also. It will be minus 1 minus minus 1. So it will be 0. So fifth order is giving you 0. Okay. It means with the help of this data which we have here in this form, this you can make a polynomial, and then the polynomial fifth derivative is 0. It means it should be a polynomial in the fourth power. Okay. Now all this table, difference table, we can make a program to find out this forward difference table. Okay. We need not to do it manually. So how to make a program for this? In order to make a program for this, you see the question was the find out the value of fifth order forward difference value. So the value is 0. We have seen it has come out 0. So if you want to program for this, first you should understand the 2D array. A 1D array I have already told you in C language. Now let us see the two-dimensional array. A two-dimensional array is also known as a matrix, a table of rows and columns. To create a 2D arrays of integers, take a look at the following example. I am declaring a 2D array. The name of the array is matrix, and here I have to give two indices, first I, second j. Okay, I would be number of rows and j would be number of columns, and those values are integers. You may take float also, but initially I am taking integers, so I am declaring them in the category of int. And then how to give the values of the matrix? So you will give, like in the curly braces, it is the first row 1 4 3, and then second row is 3 6 8. Okay, like here you have row 1, row 2, and column 1 2 3. But I told you in C we start indices from 0, not from 1. So if I am saying column 0, it means column 1. Column, if I am saying indices 1, it means column 2. If I am saying indices 2, it means column 3. Similarly, if I am saying the indices for row is 0, it means it is first row. The indices, let's say I, is 1, it means it's a second row. This is the column indices j. J is 0, j is 1, j is 2. It means first column, second column, and third column. So if you see these indices row by column, then the first box has a value corresponding to 0 0. Similarly, the second box has the value corresponding to 0 1. The third box in the first row has the indices corresponding to 0 2. So all these are written here. 0 0 will tell you first box. 0 1 will tell you the value of the second box. 0 2 will tell you the value of the third box. Similarly, 1 0 will tell you the value of the first box of the second row. 1 1 will tell you the value of the second row and second column, and it will tell you the values of the second row and the third column. So with the help of two indices, we are defining only one number, but these two indices are necessary because here we do not have a vector, either column or row vector. No, we have a matrix where we have row and column. So we have to define two indices I and j here. So you can initialize your matrix 2D array with the help of this. First you will write the element of first row separated by comma in curly braces, then comma another second 3 6 8 second row, and all should be in the curly braces again. So this is a method how to define the 2D array. And obviously always remember first indices will be for row, second L for column. So it is row by column. Okay. Now how can you access the element of 2D array? Like in this example, I have defined a array, 2D array. The name of the array is matrix, and it has 2 rows and 3 columns. So first row is this, second row is this. Now if I am saying matrix 0 2, means I is equal to 0, j is equal to 2. I is equal to 0 means it is first row. J is equal to 2 means it is third column. Okay. So it will give you the first row, third column, means first row, third column this. So this will give you the value 2. So output will be 2 here. Now how to use loop with the help of 2D array. Okay. So to for loop or while loop through a multi-dimensional array, you need one loop for each of the array's dimension. Means if you want to use loop in 2D array, it will always be nesting of loop. Means one loop within the body of another loop, because you have two indices, first I and then second j. Like for I is equal to 0, it means first row. For first row, if you see here, for first row, first indices I is always 0, 0, 0, 0. But second indices is changing, like 0, sorry, like 0, 1 and 2. It means the outer for loop will be having I is equal to 0, and then within the body of this outer for loop we have another for loop whose indices is j, and now this j will vary from 0, 1, 2, and then again when j will become 3, the inner for loop condition will be false, and then the control will come out of the body of the inner for loop to the body of the outer for loop, and in outer for loop then I will be incremented by 1, and then again I will remain 1 for next step, where out inner loop will be executed 3 times, j is equal to 0, j is equal to 1, j is equal to 2. So if you want to use array as a 2D matrix, then in the C language or in any other language, you have to use nesting of the loop to access the element of this 2D array. So let us see the program for the, let us see this program for accessing the element. I have declared one integer int. It's a 2D array. The name of the array is matrix. It has 2 rows, 3 columns. The first row has the element 1, 4, 2. The second row has the element 3, 6, 8. Now I am defining nesting of loop because I need two indices I and j. So I am taking these indices as integer. Now first for loop I am saying I is equal to 0, and this is basically the row. So row I said it will start from 0, and second row will be 1 for I is equal to 1. It means condition is I less than equal to 2, or you can say I less than I less than 2, or you can say I less than equal to 1, because we have only 2 rows. Okay, and then I plus 1, I plus plus, it is I is equal to I plus 1. Then within the body of the for loop we have another for loop which is called nesting of for loop, and now this j indices, it corresponds to the number of columns. Okay, so for I is equal to 0, now j is equal, we are starting j is equal to 0. Okay, j is equal to 0, 0 less than 3, condition is true. Now it will print f, it will print matrix ij, means 0, I is 0, I is 0, j is 0, means the first element 0, 0. So 0, 0 first element, you can say this was here, so it will print 1. Okay, then I will remain, then it will check the condition again, j will be incremented by 1, j was 0, it will become 1, j is equal to 0 plus 1, 1, 1 less than 3, condition is again true, then it will again print 0, 1. 0, 1 means 0, 1 means this second element 4, it will print 4. Then it has again j will be incremented by 1, j will become 2. 2 less than 3, condition is again true, so it will print 0 and 2. 0 and 2 means this third element 2, it will print 2. After that j again will be incremented by 1, so j will become 3. Now it will check the condition, 3 less than 3, condition becomes false. So control will come out of the body of inner for loop, so it will come to the outer for loop, where again we started I is equal to 0, now I will be incremented by 1, I will become 0 plus 1 is equal to 1. Now it will check the condition, 1 less than 2, condition is true, so control will go to the body of inner for loop with the condition that now I has become 1. So again it will start j is equal to 0 and I was 1. 0 less than 3, condition is again true, so it will print what is matrix I has become 1, j is 0. So matrix 1, 0 corresponding to 1, 0, you have this element, so it will print the first element of the second row. Now j will be incremented again by 1, j will was 0, it will become 0 plus 1, 1. 1, it will check the condition, 1 less than 3, condition is again true, so it will again print I was 1, j is again 1, so it will print the element corresponding to 1, 1. corresponding to 1 1 you have this element 6, so it will print the 6. Then again j will be incremented by 1, so j was 1, now it has become 1 plus 1 2. Now it will check the condition 2 less than 3, condition is again true. It means it will execute the body of the inner for loop where we have the printf statement, so it will print the value corresponding to this matrix 1 and 2. 1 and 2 we have this last element, so it print 8, and then j will become 3 because earlier j was 2, now j plus 1 3, 3 less than 3, condition is false, so the body of the inner loop will not be executed, control will go out of this loop, then it will go to the outer loop. In outer loop j was 1, now it will become 1 plus 1 2, 2 less than 2, condition is again false, so control will come out of the body of the outer for loop, means it will come here, and if after it is AND, program will be ended. So it will print in vertical form 1 4 2 3 6 8, means in vertical form it will print all these elements. So the matrix can be printed with the help of 2D array. Okay, and I have told you need to have two indices I and j. Why I told you this thing? Because here also, if you see in my whiteboard, this is also like a matrix. Okay. Sorry. Okay, it will take some time. It will come. It will take some time. Yes. So here in the Microsoft board, this table, forward difference table, is also like a matrix. How many rows we have? Like 1 2 3 4 5 6. We have 6 rows, and how many columns we have? 1 2 3 4 5 6 7. So we have 6 rows and 7 columns. So if you want to print these values, then you have to use 2D arrays. Okay. So how to make a program for this forward difference table? What we are doing in this forward difference operator, we are taking second term minus first term, like 11 minus 7 4. Similarly 14 minus 11, third term minus second term 3. Then fourth term minus third term 4. And again same process is repeat for the next columns also. So you have to make a program like it with the help of for loop. It will always be doing like n plus 1 term minus n term. Whatever it will be printed on the screen. Then again it will go to the indices will be higher, like n plus 2 minus n plus 1, n plus 3 minus n plus 2, n plus 4 minus n plus 3. So you have to make for loop, and obviously because it's a 2D array, it's a matrix, you have to take nesting of for loop 2 times. So let us see the program for this. So this is the program. First, I will give the values of the x and fx. Okay. So we have to give values of x and fx. So I am taking two matrix, two array. First, for the value of x. Value of x is just a simple column matrix or row matrix. So it's a one dimension matrix. So I'm defining x20. It may have maximum 20 elements, but for the sake of the simplicity, in our table we have only 6 elements. Okay. So x20 is the 1D array, and then for the values of the y, we are taking 2D arrays, because y column will come in the second, y value will come in the second column. So it will become a matrix. So maximum elements in I and j, we are taking 20, 20. We need two indices I, j, and one more indices n. N is the total number of data, like total number of values of x. So now I will give these values the element of x, like x1, x2, x3, x4, and corresponding values of y. So I am saying printf enter number of data. How many numbers of x you have? Suppose whatever I am entering 5 or 6, that is going into n. Then it will say printf enter data, means we have printed the value of x. Now it is saying sorry, we have printed the value of total numbers of x. Now it is saying enter data, means the value of x and corresponding values of function fx. So for that I am using for loop. It is saying I is equal to 0, I less than n. Okay, why less than n? Because I am starting from 0. If you will start from 1, then it will be less than equal to n. Then it is saying printf x %d is equal to I, means the first I is 0, so it will take a value corresponding to x0. Okay, and that will be saved in here ampersand sign x0. After that, it is the values of first value of x, then you have to give the corresponding function value fx. So it will say printf, it will print y, then the value like y0. So y0, it will be stored in a 2D array. Okay, and I will become 0. I has 0. So first element will be 0, 0. Like I told you here. The first element will be here 0, 0. Okay. And similarly, it will do for all n number of elements. So it will be repeated again and again till this condition becomes false. Okay, so let us see this section only, then I'll go to another section. One by one, I'll run this program. So I'll just copy it, because if I'll type it, it will take too much time. I'm just copying it from here. Control C. And then I'm just pasting my program here. Okay. And I have to take one more and sign here. Okay. So if I run this program, then you can see I'll run this program. It is saying enter number of data. So I will take the same example which I took in whiteboard. So that were having almost 6 values. So total I need 6 data. Enter the data x naught. So what was the value of x? Do you remember? Anyone? Let me see what was the value of x in that program which the value of x is 0, 5, 10, 15, 0 to 25 at a difference of 5. So the values are क्या नाम है अर्पिता? You will tell me the corresponding values of y. So first values of x is 0. Okay, then it will ask corresponding value of y. The first value of y was in this example 7. Then enter. Then what is the value of x1? After 0 it was 5. Corresponding values of the function is 11. Then x2 it was 10 because it's a difference of 5, and the corresponding values is 14. Then another value will be 15 after 10, and then corresponding values of y was 18 in that example. Then another values of x will be 20, and corresponding values was 24. Then last values of x will be 25, and the corresponding values was 32. Okay, so we have given this all this data in of the 2D array here, like the values of x, x0, x1, like this, and then corresponding values of y. Okay, so up to now this program is this only. If I will enter, then it will say code execution successfully. So this is how to give the values of a 2-dimension array to the through the program. Now let's come back to our program. Our aim is to make a forward difference table with the help of C program. Now generating forward difference table, I told you you have to use for loops, like 2 for loops in form of nesting. Okay, so first for loop is for the row I is equal to 1. You may start, we are starting from I is equal to 1, and then I less than equal to n, I plus plus. Okay, why we are starting from I is equal to 1, I will tell you. Okay, then in the inner loop we have for j is equal to 0, j less than equal to n minus I, and then j plus plus. Okay, so this code basically will generate forward difference table. How it will generate? Let us see here. We will start with I is equal to 1. Then condition is I less than equal to n was 6. I less than equal to 6 means 1 less than equal to 6. Condition is true. It means body of this outer loop will be executed, and this is the body of the outer loop where we have one more for loop. Now I is 1, j will initialize with 0, j is equal to 0. It will check the condition 0 less than n minus I. N was your 6, I was 1. 6 minus 1, 5. Okay. So 0 less than 5, condition is true. It means body of this inner for loop will be executed. Now in this inner for loop, j is 0 and I is 1. So it will say y 0, 1. Okay. Is equal to. Then it will say y j is 0, 0 plus 1, 1 means y 1, and then I minus 1 means I minus 1 means 1 minus 1, 0. So it will say y 1, 0 minus y 0, 0. Why I have taken I is equal to 1? Because here I have I minus 1. Because I told you, you have to take second term minus first term. Okay. Second term minus first term, if I am saying in this value of y, it means second term minus first term, if you see in this table, it is like 0, 1 minus 0, 0. 4 minus 1, like this. If these are the values, suppose. Okay. Then 2 minus 4, it will be 0, 2 minus 0, 1. So you have to create the program is in that manner that with the help of two for loops, you will be covering like 0, 1, this minus this, or 0, 2, this minus this. Similarly like this. Okay. So we are covering all these steps so that this for loop will create all the first order, second order, third order. Okay. Now it has generated all the differences. Now it will print. So in order to print forward difference operator, again we will do the same thing. We will use two for loop in the form of the nesting. So first for loop is I is equal to 0, I less than and I plus plus. So it will give you I is equal to 0, I less than 5 means 0 less than 5. Condition is true. It will go inside the body of the outer for loop where we will print f 0.2. 0.2, I mean it's an integer, you can take d also. And then x0. X0 means the first value of x will be printed, because in first row like this in this table we have to print like this, or maybe output I'll show you. This output will be like this. First, in the first column it will print 40, 50, all these element of the values of the x, and in second it will print like all these values of the y. Okay. So with the help of this displaying the table, it will first print the values of x0. Okay. Now again it will go to the inner for loop. We have I is equal to 0. Now j is equal to 0. 0 less than 6 minus 0. 0 less than 6. Condition is true. Then it will print in the second column, it will printf y. Your I was 0, your j was 0. So y 0, 0. Y 0, 0, if you see the first element, it will print. Okay, in the second row. So in that manner, now I will remain 0 only, but it will for the 0 only, because for the first column I will remain 0. Okay. It will print all the element with the 0, 1, 0, 0, 0, I, y, I, j means y 0, 0, then y 0, 1, then y 0, 2, then y 0, 3, y 0, 4, y 0, 5. As soon as j will become 6, this condition will become false, and then it will come back to this. It will print one blank line, because we have to move to the new line. Then the control will come here, then it will move the cursor to the next line, and then again I will be incremented by 1. I will become 1 plus 0 means 1. Okay. So now it will print all the values of y with I is equal to 1, and again j will be changing. Okay. J will be changing from 0 to 5. So first it printed y is equal to 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. Then it will print another in the another column. It will print 1 0 1 1 1 2 1 3 1 4 1 5 like that. So in that manner it will print all the difference table. So let us run this example again. I'll just copy the complete program now, generating forward difference table and printing the table. Okay, so this is our complete program. Now, Ankita, one more time you have to tell me this data. I will again run this program. So it is saying a number of data, there are 6 numbers. Then it is saying x0 was 0, the y0 was 7, then it was 5, then another value was 11, then it was 10, then y is corresponding y was 14, then next values of x is 15, then corresponding values is of y is 18, then x values is 20, and then corresponding values is 24, then we have x values is 25, then corresponding y value is 30, 32. So these all values I have given. This is the same values which I use here. I'm just using this program 0 5 10 15 20 25, and then corresponding y values is 7 11 14 18 24 32. All these values I have given here. Y0 7, y11 y1 11, y2 14, y3 18, y4 24, and then y5 32. Okay, so I have entered the data, then I will click enter. Now it is generating forward difference table, and you can see final form, like first of all, this is for first forward, this third column is for first forward difference, this is second forward difference, third forward difference, fourth forward difference, fifth forward difference. So fifth forward difference is giving you answer 0, and we have done it manually also. Fifth forward difference was 0. Only thing is that in manually we are making it like in a conical shape, but in practice in computer it's not coming in a conical shape, but we are getting the answer. Okay, so you can easily make the program for the forward difference table, and similarly you can make a program for the backward difference table. And here also there are 3 parts in program. First part is called input section, which is given here. Okay, in this input section you have to enter the data with the help of for loop. It will ask you to enter all the data. Okay, like we have entered the data from here to here. This here to here we have entered the data. Now second, it will generate forward difference table, means the value corresponding to each column, like this 11 minus 7 4, 14 minus 11 3, 18 minus 14 4. So it will keep in the memory all those values will with the help of these two nesting of the for loops. And then third, how to display it, same with the help of two nesting of the for loops, we can display the forward difference table. Okay, so this is the program for generating forward difference table, because it involves matrices. Matrices are two arrays, so 2D arrays. So you will, so I stop here. If you have any question, you can please ask me here. You can write in the chat window if you have any question. Anyone if has any question, they can ask me. Hope it is clear to you, because I know it takes time in writing, so I'm just waiting for another 2-3 minutes, so that if you want to write, it's you can write it. Okay, I'll be waiting for 2-3 minutes for your questions. Thank you, Brinda. Brinda is saying it is clear. I suggest you to run these codes. Try to write the codes in the C compiler, online compiler, then it will be more clear to you. Okay. Once you will be accustomed in writing all these codes, then it will not take much time for you to understand the codes. In the initially, it may take some time, but it's always good to write the codes in order to clear your doubts. Whatever doubt you have, you just play with the codes, change it, and then see whether you are getting the correct result or not. We will be more comfortable. Okay, thank you, Surya Rao. Okay, so it seems to be okay. So my start this video. Okay, so I stop here, and I'll be sharing all these notes and lectures, notes of the lectures, as well as the YouTube recording of this lecture today in the evening. And for the PPTs of Professor Jitendra Kumar, I have already shared, but I think I forgot to publish it. I will publish it now so that you can access those slides as well. Okay, so it will be our effort to upload all the necessary files and the YouTube recording at the last of each day, so that in the evening, suppose you have missed something, you can go through those recordings as well as the PPTs, and you can take the benefits from that recording as well as PPT notes. So if I can still see many of you have not yet joined the Canvas. I am daily sending the invitation. You will get an email from the Canvas that Dr. Rahul Singhal has invited you to join the Canvas. Once you will click on that, you will go to the browser, will take you to the Canvas window. There also you have to accept the invitation. But I can see many of you have not yet joined the Canvas. So please, those who have not joined the Canvas, please join it. And on the last day of this FDP, which is I think the 17th, so we will be 17th is the last day. We will be having a quiz, or maybe we will be having two quiz. One quiz will be of 1 hour. So in the afternoon session, we'll be having two quiz, and then in each quiz there will be choice questions. You will be sitting on your like using your mobile device. There will be choice questions online. You have to solve those quiz, the questions related to the lectures, related to voice is breaking. Okay, so maybe my voice is not so clear. I am saying that on the last day of the lecture, which is on 17th, there will be a quiz also. In the quiz, there will be 20 multiple choice questions, like objective type of questions. You have to attempt it in online mode. It will be open for 1 hour, and then those who will be able to successfully complete the quiz, they will be eligible for the certificate. Okay, so there are two requirements for the certificate. One is that you should have attendance more than 75% throughout this course. Second is that you should qualify the quiz also. Okay, quiz will be at the last on the 17th of June in the afternoon session. There will be two quizzes. One quiz is for 1 hour. Okay, and on the basis of the result of the two quizzes, we will make you that you have successfully complete the course and you are eligible for the certificate. Ankit, voice is clear? Okay. So now I stop here. All the best. Again, we will meet at 4 p.m. We have, I think, another lecture today at 4 p.m. by Professor Ritesh. Okay. Bye bye. Good day.